Imagine for a moment you're a student, maybe 100 years ago, maybe even earlier. Your classroom is simple: wooden desks, a chalkboard, and heavy books. The teacher talks about the planets, the sun, the moon, describing their movements through the sky with words and chalk diagrams. It's abstract, hard to picture. Now imagine the teacher unveils something extraordinary. A mechanical model of the solar system, a miniature cosmos of brass and wood, gears clicking and turning, planets on long arms circling a glowing central sun. Suddenly, the universe isn't just a concept in a book. It's a machine you can see, you can almost touch. The awe in that classroom would be electric. You'd see the Earth's tilt causing seasons, watch the moon orbit our planet, and understand why Mars sometimes appears to move backward in the sky. It's no longer just astronomy. It's a revelation. This isn't just about looking at planets. It's about understanding the elegant, predictable mechanics behind everything. The questions would start pouring in. How do the gears work? Why is this planet faster? Can we build one ourselves? This brings us to a fascinating idea: the seeds of STEM. Long before we had a name for it, this single device wouldn't just be a science lesson. It would be an engineering marvel right there in the classroom. Students would be seeing practical mechanics in action. They'd be tracing the relationships between gears, ratios, and orbital periods. It's hands-on learning at its most profound. This model would spark a different kind of curiosity. It's not just about what's in the sky, but how we can model it, predict it, and build something to represent it. It's the birth of a systems thinking mindset. They'd be tinkering, sketching, trying to build their own simpler versions. They're not just memorizing facts. They're developing an intuition for physics and mechanics. This kind of tool demystifies science. It makes it accessible and, more importantly, incredibly exciting. It shows that the complex dance of the cosmos can be understood through logic, math, and craftsmanship. Think of the early spark it would ignite in future engineers, mathematicians, and inventors. Now let's take this thought experiment one step further into the realm of forgotten futures. What kind of world would that have created? Consider the potential career paths that might have opened up. A generation of young minds, fluent in the language of mechanics and celestial motion, would enter the workforce. Perhaps the Industrial Revolution would have taken a different, more nuanced path, driven by people with a deeper understanding of complex systems. Maybe advancements in clockmaking, navigation, or even early computing would have been accelerated. Think about the scientific breakthroughs. Early exposure to a physical model of the solar system could have normalized concepts that were revolutionary at the time. It might have spurred earlier and more widespread acceptance of heliocentrism. More minds would be primed to ask the next big questions. Could we use these same principles to navigate the seas more accurately? Could we build machines that predict tides or even weather? When you give people a powerful tool to visualize and interact with a complex idea, you don't just teach them that idea. You empower them to build upon it, to innovate, and to dream bigger. We can only wonder about the scientific giants who might have been inspired, the technologies that might exist today, and the alternate history of discovery we might have lived. What other inventions could have changed history if they appeared earlier? Let me know in the comments below. Thanks for watching, and if you enjoyed this journey through a forgotten future, be sure to subscribe for more.